So the last part of this discussion is going to focus on demonstrating the performance of collectors, concurrent and non-concurrent, of course. And so we're going to take a look at these performance differences, and the place to find this information, if you want to run it yourself to see how it works on your platform, or if you want to fiddle around and change any parts of the test program just to see what happens, is my EX14 folder in my GitHub repository. So recall that concurrent and non-concurrent collectors perform differently when used in parallel and sequential streams for different input sizes. And that's really important, and we'll kind of talk about that when we get to the results part. Just a quick reminder, kind of a recap. A non-concurrent collector operates by merging sub-results together. So you can see here we have these different threads, and the results will be merged together. So different threads operate on different instances of the intermediate result containers, and therefore, as we talked about before, there'll be some merging overhead. In contrast, a concurrent collector will create one and only one mutable result container, and then it'll accumulate elements into it from multiple threads in a parallel stream. And so we have the concurrent result container, the one and only. The big benefit here is there's no need to merge intermediate sub-results, which can be a win under certain circumstances. So to kind of test out and see how this works, these are some performance differences that arise when you run the program. Now, I'm just going to talk through the performance results, and I'll point you to a video that walks through the code in great detail, but I didn't want to duplicate that because you can always go watch it. But here's the big thing to notice. What we end up doing here is we end up having all the words of Shakespeare, all the words in the works of Shakespeare, and we're going to have both sequential and parallel streams, which will then, of course, trigger the use of concurrent and non-concurrent collectors. So we've actually got four things that are orthogonal. We have parallel and sequential streams, and then we have concurrent and non-concurrent collectors. And so as you can see here, when you have a small number of words, when we have just 1,000 words of Shakespeare, then there really isn't much difference in performance, number one. And the other thing to notice is that the sequential implementations, especially the non-concurrent collectors, actually perform best. And that should not be surprising. We'll talk more about this when we talk about when not to use parallel streams. But the long and the short of it here is that when n is small and there's not much going on, parallelism actually exacts a price because you've got all this extra ceremony to set up the splitterators and the joining and so on. So it's not really a win. As we start having more words, now you can start seeing some interesting things happen. Notice you'll see here that the parallel implementations, whether they be the parallel version that uses the concurrent collector or the parallel version that uses the non-concurrent collector, are starting to perform better than sequential versions, which isn't a big surprise, but you'll notice that there's also not, it's not wildly different. And you'll also see that it's not wildly different between the time for using a concurrent collector versus a non-concurrent collector in parallel. They're relatively close. They're in the ballpark. When we take all the words of Shakespeare, all 883,311 unique words, and we do stuff with them, now you start to see that using parallel streams and concurrent collectors are a big win. In this case, lower numbers are better. That means it took less time to do the collecting. You'll also see that the parallel versions are, again, faster than the sequential versions, but you'll see that the concurrent collector is now, roughly twice as fast or so as the non-concurrent collector, showing again that as n gets bigger, the win from parallel processing goes up. So that's the key thing to observe from that particular test. And to learn more about this, if you go to this video on my website, which is called A Performance Comparison of Java Splitterators and Collectors for Various Java Collections, which is part of my Functional Programming in Modern Java playlist. That's a walkthrough in more detail, because it's like 11 minutes of walkthrough that walks through the code and looks at it in great detail. So if you want to see all the full-blown glory and analysis of the code and how it works, please go ahead and take a look at that.